Hi class. In this video here, we're going to move into section 4.1 and talk about Pythagoras and his hypotenuse. And so what this really is going to be just a quick introduction to is what's called the Pythagorean theorem. That's what's going on in this chapter. And it says this: in any right triangle, okay, the square of the length of the hypotenuse. And so what the length of the hypotenuse is, it's the longest side of a right triangle. It's also the side opposite the 90-degree angle. Here would be the 90-degree angle. This square of the length of that is equal to the sum of the square of the lengths of the two other sides. And so if we let A and B equal the lengths of the sides of a triangle and C be the hypotenuse, all right, whatever the length is, it turns out that A squared plus B squared will always be equal to C squared. So what this is saying is the lengths of these sides have to be such that A squared plus B squared is equal to C squared. And I won't do it in this video here, but it's really fun to read in the textbook, the proof that's presented. It's a good read, it's interesting, and it's cool how it's derived. And so all I want to do in this quick video here is just 3 application problems of how you use the Pythagorean theorem. All right, so here will be the first one. Okay, and I'm a sports guy, so baseball is my favorite sport, so I thought I'd pick this one. So a baseball diamond is really a square measuring 90 feet on a side. So what that means, if you have home base, to get to first base, it's 90 feet. To get from first base to second base is another 90 feet. Second base to third base, this length right here is 90 feet. And then back home is 90 feet. So how far does a catcher have to throw a ball to get it from home plate to second base? So imagine a base runner's trying to steal second, and the catcher throws the ball. So how far does the ball have to travel? So what we're looking for here, if this black line represents the length the ball has to travel, what we're looking for is the length of this black line. And so what you see here is if you ignore everything else and just look at this right shape right here, you see a right triangle, okay? Which means that this is the hypotenuse right here, that length. So we just use the Pythagorean theorem. A squared plus B squared is equal to C squared. And I know that the two sides right here are both 90 feet. So 90 squared plus 90 squared has to equal C squared. So 90 squared is 8,100. Okay, so if you have 8,100 plus 8,100, that gets you to 16,200. And then the way you would solve, remember, this is equal to C squared. So to undo a square, you would take the square root. And the square root of this ends up being 127.28. I rounded up there, feet. Okay, so that's how far away it is for the catcher to throw. Let's do another one. And now I have two Mindscape problems here for the next two so that you can see. All right, so these are problems from the textbook. And this one is about assessing area. Suppose you know the base of a rectangle has a length of 4 inches. Okay, base of a rectangle, length of 4 inches, and a diagonal here of 5 inches. I want to find the area of this rectangle. Okay. So look, here's what we know. We know the area of a rectangle is equal to length times the width. But you know what? I don't know what the width is. I don't know. But we can find the width. Because if I just ignore the rest of this part here, I see a right triangle. Okay? I'm given the hypotenuse. I know that's 5 inches. That's the longest side. I know this length is 4 inches, so I can use that information to find this one right here. If I have A squared plus B squared is equal to C squared. If this is my A, that would be 4 squared. I don't know what the width is. I don't know. So I'll let width be B. So then the B squared has to equal the hypotenuse squared, which would be 5 squared. Well, 4 squared is 16 plus B squared, 5 squared is 25. What I would do is I would subtract the 16 over, and 25 minus 9, or 25 minus 16 is 9, excuse me. That's B squared. So to just get B, I take the square root, and the square root of 9 is 3. So now I know the width is 3 inches. So now I can find the area. All right. It's the length, which is 4 inches, times the width, which is 3 inches. 4 times 3 gets me 12, and inches times inches get me square inches. All right. So not too bad. This one here, it's just like, if you're given 2 sides of the triangle, you can use it to find the other side is basically what's going on here, as long as it's a right triangle. All right, here's the last Mindscape. On a sunny, warm day, a student decides to fly a kite on the college green just to relax. His kite takes off and soars. He lets all 150 feet of the string out and attracts a crowd of onlookers. Okay? There's a slight breeze, and a spectator. So here's the student. This isn't really great drawn to scale, but here's the student, and a spectator 90 feet away notices that the kite is directly above her. Unlike a real kite, this math question kite has a string going in a straight line, okay, from the student to the kite. So it's perfectly straight. So how high is the kite from the ground? Okay. Well, if it's standing right above and you're at the ground, you could think of this as a 90-degree angle. So it's a right triangle. So I know the hypotenuse. I know this length. I just don't know the height. So I again would use a squared plus b squared is equal to c squared. I'm going to let the height, how high up it is in the sky, be a. So a squared plus, I know this distance here is 90. So 90 squared is equal to the hypotenuse squared, which would be 150 squared. So we saw 90 squared is 8100. So a squared plus 8100 is equal to 150 squared, gets you 22,500. Subtract over the 8100, and you get a squared is equal to 14,400. Well, just to get a, you take the square root of that. And that kite, even though the string is 150 feet, remember it's shooting at an angle. The height is the kite is 120 feet in the air. Okay, I hope this video helped kind of see the uses of the Pythagorean theorem. And again, read the textbook for the proof and a few other examples. And I'm always here to help.